In this video, I'm going to explain the interest and appreciation depreciation word problems. Before we get to the problems, let's look at the formulas used in here. The first one, we need to look at the continuously compounded interest, which is A is equal to P e to the power of RT, where A is the amount of money in the account including the interest earned, P is the initial investment, R is the annual interest rate, and T is the time in years. Compound interest, A is equal to P times 1 plus R over N to the power of NT. A, the amount of money in the account including interest earned, P is the initial investment, A is the annual interest rate, N is the number of times the interest is compounded per year, and T is the time in years. Appreciation, VT is equal to P times 1 plus R to the power of T. VT is the appreciated value of the item, P is the initial value of the item, R is the fixed rate of the appreciation, and T is the time in years. Finally, depreciation, VT, P times 1 minus R to the power of T. The only difference between the appreciation and depreciation is this the interest rate is added and this is subtracted. So VT is the depreciated value of the item, P is the initial value of the item, R is the fixed rate of the item, depreciation, and T is the time in years. Let's look at a few examples under this category. The first question is, the Crafts invest $3,000 at 7.2% interest compounded continuously. Determine how long will it take their investment to be worth $10,000. Let's underline the keyword, which is compounded continuously, and we are looking for how long will it take their investment to be worth $10,000. So the formula that we are going to use is the continuously compounded interest, A is equal to P e to the power of RT. So we are going to use that formula. A is equal to P e to the power of RT. Let's put the values. A is 10,000 and P is 3,000 here. E to the power of RT, the rate of interest is 7.2, so 7.2% is 0.072, then T. We can cancel out the 3 zeros, that means they divide both sides by 1000, so you get a 10 is equal to 3, 10 is equal to 3 e to the power of 0.072 t. Now apply natural logarithm on both sides. You can even bring that 3 down here, so this becomes 10 over 3 is equal to e to the power of 0.072 t. When you apply natural logarithm on both sides, you get ln of 10 over 3 is equal to that goes to the front, which is 0.072 t multiplied by ln e, and we know ln e is equal to 1. That is right, there is 1. So that means ln 10 over 3 is equal to 0.072 t. That gives you the value t is equal to ln 10 over 3 divided by 0.072. Using a graphing calculator, the t is approximated as 16.72 years. Correct to 2 decimal places. Another example where the interest is compounded every 3 months. Determine how many years it will take a sum of money to double. Just look at the keywords in here. In value when it is invested at 8.2% interest compounded every 3 months. When we look at the formula sheet, you can see the formula that we are going to use is the compound interest, compounded semi-annually, quarterly, things like that. So this will be the one we'll be using. A is equal to P times 1 plus R over N to the power of NT. Okay. A is equal to P times 1 plus R over N to the power of NT. We got the values. A is actually, we know the money is supposed to be doubled in the time period, so it becomes a twice P because it is doubled. So 2P is equal to P times 1 plus 8.2% is 0.082, which is supposed to be divided by 4 because we know to the power of 4t, and again that 4 goes over there, that is 4 times t. Let's do the math. The p cancelled out from both sides, so that becomes a 2 is equal to, we need to combine 1 plus 0.082 divided by 4. When you combine and do the math, you get 1.0205 then to the power of 4t. Apply log on both sides. You can apply common logarithm. When you apply common logarithm, you get log 2 is equal to 4t multiplied by log 1.0205, or t is equal to, when you keep the t there, you need to bring 4 log 1.0205 below this one, I mean to the other side, actually as a division. So log 2 divide 4 log 1.0205, and finally using a graphing calculator, the t is approximated at 8.54 years, correct to 2 decimal places.